This microcredential addresses compression concepts in small engines and consists of 4 targeted skills. This targeted skill deals with compression testing. A technician needs to investigate possible conditions that would cause low compression in an engine. Several methods are available. The first method is the quickest and easiest. Simply spin the engine with the starter, whether it's manual or electric. Easy pulls should be felt, followed by difficult pulls. Those variations are the engine's progression through the strokes of the cycle. If only easy pulls are felt, the compression is low. After about 4 pulls, remove the spark plug and pull the engine over again. With the plug removed, there can be no compression, so the engine should be the easiest to pull. Although this method is not measurable, it can give a sense of the available compression or lack of it. The technician can quickly decide if compression is acceptable, and if so, can move on to other diagnostic checks. If troubleshooting a twin-cylinder engine with an electric starter, the technician can still get a sense of the amount of compression present, although there is no manual starter to pull. Another method used to check compression is with a compression gauge. With this style gauge, the end of the gauge simply gets pushed into the spark plug hole. Other styles thread in. Different adapters are provided with the tool to fit different spark plug hole diameters. Be sure to snug the fitting into the plug opening. Next, pull the engine over several times. After about 4 pulls, the reading on the gauge will reach a maximum. Note that reading. A person may have to check the manufacturer's specifications for the engine to determine what compression pressures are acceptable and what are not. Low pressure indicates some kind of mechanical failure. Medium and high pressures are good. Measure the pressure of each cylinder if working on a twin cylinder. The compression pressure should be very similar in each cylinder. Differences will easily identify the faulty cylinder. Measuring with a gauge is accurate in the sense that it will provide specific pressures. However, it will not indicate which components are the root cause of the low compression problem. Further investigation will need to be performed. The last method used to check compression is a leak-down tester. It's available from engine manufacturers or other tool companies. The gauge on a leak-down tester often shows cylinder pressure using colors. Red indicates the cylinder is leaking badly, indicating failure. Yellow shows some leaking but is still passable. Green shows almost no leakage and is good. Other tools have gauges with numerals on the dial face to indicate actual pressures. With a leak-down tester, air is pushed into the cylinder rather than measuring the pressure of the outgoing air. First, adjust the air pressure that will be forced into the cylinder. Just any pressure is not acceptable. There is a small regulator on the tool. Connect the tool to an air line, open the flow control valve, and set the air flow through the tool with the regulator. On this gauge, there's a mark indicating the set mark. Different tools and different manufacturers use varying set pressures. Once the set pressure is adjusted correctly, close the flow control valve. Turn the engine over by hand so that the engine is at a precise spot. That precision spot is when the piston is about 1/4 of an inch down in the cylinder after top dead center, or ATDC. This setting can be achieved easily. Insert a screwdriver into the cylinder through the spark plug hole. The piston will push the screwdriver upward, going to TDC. Feel the screwdriver moving downward after TDC. Gauge the 1/4 inch movement on the shank of the screwdriver. Placing the engine in this spot at this time in the cycle is very important. Any compression release device is not engaged. Therefore, no compression will be released, and the most accurate reading can be made. Also, the flywheel or crankshaft needs to be locked so that they cannot move. Otherwise, when the sudden push of air is injected into the cylinder, it will make the piston move and ruin the test. If a leak-down test is to be performed on a twin cylinder, each cylinder will have to be prepared the same way. Remove the air filter, loosen the oil dipstick in the oil fill tube. Fasten the hose into the spark plug hole, then attach that hose to the leak-down tester. Open the flow control valve to allow air into the cylinder. Listen carefully for sounds of air escaping. A slight hissing sound coming out of the muffler indicates that an exhaust valve is leaking. If air is coming out of the carburetor, an intake valve is not sealing. Now, if air movement is coming from the breather or oil dipstick, either the cylinder, piston, or rings are leaking. If air is passing past those parts and coming out into the crankcase, compression is obviously leaking. Sometimes air escaping from around the cylinder head can be heard. This would indicate loose head bolts, a failed head gasket, or a cracked head. Read the gauge on the leak-down tester. Red indicates failure, a high cylinder leakage. Yellow indicates moderate or poor compression, but acceptable. Green indicates low leakage and good compression. Some manufacturers suggest having the leak-down test done with the piston at the top of the cylinder. Others want the test done with the piston at the top and bottom of the cylinder. The leak-down test is by far the best way to pin down exact causes for poor compression. However, it is time-consuming to perform. Is it worth the labor and cost? Probably not for a single-cylinder mower engine. The engine or entire mower could be replaced inexpensively. But for a twin-cylinder commercial zero-turn engine, it would be worth rebuilding rather than replacing the engine. Several procedures exist for diagnosing and repairing engine compression problems. Knowing which steps and tools to use is important for faster, more successful repairs, hopefully better customer satisfaction, and the quick return of the equipment to the user.